Hello everybody. In this video lesson we will talk about satellite and its orbital velocity. And under this subject we will learn what is a satellite, how do satellites orbit around the planet, and also calculation of satellites orbital velocity. Let's go. Satellites. A satellite is an object orbiting the Earth, the Sun, or another massive body. Satellites can be classified in two categories as natural or artificial satellites. An example for natural satellites are moon orbiting the Earth and planets orbiting the Sun. And artificial satellites are constructed by engineers and launched from the Earth for various purposes, such as communication, scientific research, weather forecasting, gathering intelligence, and etc. Until now, we have learned what is a satellite and their functions. Now, let's learn how the satellites orbit around the planet. Imagine that on Earth we have a giant rock. From the top of the rock, we will throw a stone with a velocity. It falls to the distance. And again, we do the same thing with a bigger velocity, and it falls farther the first one. And again, if we increase the third stone's velocity, it falls farther than the first two stones. And there's a question. Can we throw a stone with a velocity which allows this stone orbit around our Earth and not to fall? The answer is yes. And this velocity is called an orbital velocity. And let's see how to calculate the orbital velocity. Think that this is our planet. This is a satellite, artificial satellite, and orbiting the planet. This m is the mass of the planet, small m is the mass of satellite, this v is the orbital velocity of the satellite, and the r is the distance between the satellite from the center of the Earth. This is important. The distance must be taken between the satellite and from the center of the Earth. And of course there's a force between the planet and the satellite. This is a gravitational force which has the formula. This g is the universal constant times the masses of satellite and planet over the distance square. And also, because of the circular motion, there's a centripetal force. And also it has the formula mass of satellite times square of satellite's velocity over the distance. And these forces are equal to each other. This is in equilibrium or in balance. And also their formulas. Here we have two masses on both sides and we can cancel them. And there are also two distances on opposite sides and we can cancel one of the square of the distance with another. And this velocity square will be equal to g times m over r, as you see here. And when we get rid of this square, we get the orbital velocities formula. This is in square root gravitational constant g times mass of planet over the distance between satellite and the center of the planet. Okay, we have learned what is a satellite, how do they orbit around the planet, and the calculation of the orbital velocity. And now let's comprehend our knowledge by solving a problem. This is our question. Question is this. The Hubble telescope is in orbit 600 kilometers above the Earth's surface. Question is this. At what speed is the telescope traveling? This is our Hubble telescope orbiting around our planet, which has a mass m, radius r, and then the height of the planet from the surface of the Earth is h. This is 600 kilometers. And now let's first write the given. You know that universal constant g is 6.67 times 10 to the power of minus 11, which has a unit Newton times meter square over kilogram square. And also Earth's mass is 6 times 10 to the power of 24 kilograms. Radius of planet Earth is 6.4 times 10 to the power of 6 meters. And then the height is taken also in meters. It will be 0.6 times 10 to the power of 6 meters. And of course, we are asked to find our orbital velocity. Solution. We have learned the formula for orbital velocity, which is in square root gravitational constant times mass of planet over the radius, or the distance. Here is the important point. This r is the distance between this satellite and the center of the Earth. So it must be the sum of these two numbers, 6.4 times 10 to the power of 6 meters plus 0.6 times 10 to the power of 6. It will be, of course, 7 times 10 to the power of 6 meters. And when we put these numbers in the formula, we get that universal constant g times planet's mass over the distance. And here, first, we should work with the units. Here we have masses on denominators. We can cancel one of these meters. Sorry, this is meters, not masses. And also we have kilograms on denominator and numerator. We can cancel them. And when we multiply these two numbers and divide, we get 57.17 times 10 to the power of 6 meter square over second square in square root. And one more question is here. Where this unit come from? We have worked with units and we got Newton times meter over kilogram. Here we have meter square over second square. Let's see. We got Newton times meter over kilogram. This red one is the unit for gravitational force. This is Newton over kilogram. Also, gravity has another unit as gravitational acceleration. Instead of Newton over kilogram, we can put meter per second square. And when we replace it, we get meter times meter, meter square, over the second square. And this unit is replaced or placed here. And when we calculate this root, we get the result, which is 7560 meter per second. That's all for our video lesson for now. If you have any problem or question, don't hesitate asking to your teachers, and of course they will help you in pleasure. Thank you.